I'm going to talk today about the value proposition behind mobile health and where things are going in mobile health technology and standards. So this has gotten the hashtag on Twitter, which is very common in the mobile connected world of mHealth. And so the question that I would pose is what does it mean to be mobile health? And it refers to a very broad scope. It is the use of mobile and wireless technology in the delivery of care to individuals and populations. But it is only meaningful in conjunction with e-health, with electronic healthcare, which includes information exchange. It's not useful for something to just simply be mobile if it's not able to connect and communicate. So this is a very rapidly emerging market. We see that in terms of medical applications that run on mobile devices, a steady growth of about 25% annually. We're seeing very large estimates of the value of the mobile health market. We're seeing that in terms of the number of users of mobile health applications, they're running on your mobile devices, they're running on your phone, in the millions, and several thousands of different applications that are being used already in a market that just emerged only a few short years ago. There are now 13,000 applications and 44 million users of those applications. So as we look at the value proposition, one of the key drivers for the adoption of mobile health is the availability of devices. So I have some questions for you in terms of when these different events occurred. So recently, there have been more smartphones shipped than computers. Does anybody know when that occurred? Okay. Recently as well, tablet shipments. Tablets like this have reached about half of PC sales. And they are expected to exceed PC sales sometime in the near future. And when we talk about mobile health, it's not just smart devices. It's the simple handheld cell phone that supports SMS. And you'll see that more than half of populations in the third world have some sort of cellular service. It may not be a smartphone. Let's look at these days. 2011, more smartphones were shipped than computers. Tablets have exceeded half of PC sales in the last year and are expected to exceed PC sales in 2016. And in 2010, more than half of the population in the third world were cell phone subscribers. This translates for healthcare into greater availability of care for patients, into the ability for individuals, patients, to have greater access to health data, also to providers being able to have more mobile access. You can get software today that will run on a tablet that will allow you to read an EKG, that will allow you to actually access a radiology imaging report. You can get mobile devices about this size that will allow you to do an ultrasound. So you have greater access to data, you have greater access to diagnostic test information. As a patient, you have greater access not just to your own health data, but to health information about what will keep you healthy, about what does this drug do, about what does this lab test mean. So you have greater health literacy. You can reduce the amount of time to service because you don't have to fax a report or wait until somebody can get into the office to look at an image or an EKG. And what this can also do is reduce utilization of facilities. It can reduce lost time due to patients having to travel instead, where they can receive services from their home. And also increases patient satisfaction as they have better health, better care, faster care. There's an application today with a device that you can use with your smartphone to take a picture of the ear to send to the doctor, and the doctor can look at it or diagnose what kind of problem you might have. Is this an ear infection that needs antibiotic treatment, or is this require some other sort of treatment so that you can get care for yourself or your children? So a lot of value potential in mobile health, but there are also a great number of challenges. One of the challenges in mobile health, and for those of my colleagues who are here from the US, we're understanding this greatly. We're used to having our cell phones connect to the network for which we have internet service, and when we get here, we don't have that. So we don't have the connectivity. We're learning what it's like to not have the connectivity we've grown used to. So connectivity becomes a challenge where you have regions that don't have the same level of connectivity, where you don't have broadband access, where you can't send large images, or where you don't have coverage in remote regions. Another challenge with mobile health is that the technology is outpacing policy. Medical device regulations struggles to deal with the speed at which healthcare applications are being developed for these devices. This, in my country, is not a medical device, and yet I will load software onto it, and it could become a medical device, or attach something to it, and it would become a medical device. And so this becomes very challenging, especially for innovators who are trying to do things with these devices in very creative ways, and encountering something that they've never encountered in software before because they're working in healthcare, which is the regulation associated with the devices. In the US, one of the challenges we have for telehealth is providers being able to get paid or reimbursed for providing the services, even though it might provide better outcomes for the patient, lower cost of care. If they can't get paid for it, why would they provide that service? Why would they go to the expense of deploying the infrastructure they need to provide those services? In terms of privacy and security, one of the issues is that in mobile health, the standards are still evolving. And that is also true in other areas of interoperability in mobile health. But you also have the problem of how easy this is to steal. And so if you have health data on this and it gets lost, if it's your own personal device and it's your own health data, maybe that's not as much of an issue. But if it's a physician's device and there's data for thousands of patients on this, it becomes a huge challenge. And then you have a whole movement of, in the business world, where people buy their own devices and they bring them to work and they want to use them at work. Many doctors are buying their own iPads and then bringing them into the hospital and wanting to be able to connect them to the hospital IT network. And so now the hospital IT has to figure out, is this okay? How do I secure this? how do I make sure that any data that provider has on it is no longer there when they leave my premise, so that that data is protected and secure. And then in the devices, you have a great deal of diversity. You said it's a broad area. It could be SMS text messaging on a old-style cell phone. It could be a smartphone. It could be a tablet. It could be, you know, an embedded device that is, if I can find it, you know, a device this small that just keeps track of your fitness or monitors some other aspect of your health. It could be a purpose-designed medical device that has wireless connectivity built in, and maybe has a few buttons and no display. It could be something that has very limited storage, like the Fitbit, or a great deal of storage, or it could connect to the cloud and use the cloud for its storage. You have devices that use Wi-Fi, that use Bluetooth, that use Zigbee. You have some devices that are able to sense their position, some which have video capability, others which can text information. And then you have a weight scale, a blood pressure cuff, a glucometer that are wirelessly enabled and able to communicate to providers. And so this is not just all about this or all about the tablet. Mobile health is almost as wide as, say, imaging in terms of the different kinds of things that you could do. We also see for developers of these applications that there is no dominant platform. There are many different types of devices, different form factors. You have different operating systems. You have Apple's iOS, you have Android, you have Windows Mobile, being some of the platforms that people are deploying for, and I'm sure before the end of the year, there will be more. And then as an application developer, you program in a programming language. It could be Objective-C or Microsoft C# or Java. And one thing that we are seeing that's consistently available on all platforms is some new emerging standards. I'm going to try to turn this off because John's tweeting my talk here. HTML, HTML5, CSS, and JavaScript. So we're starting to see some standards which are able to be used. There we go. In terms of emerging standards, there are a number that are currently in development. So we have in IHE, in IT infrastructure, the committee that John is a member of, we have something called Documents for Mobile Health, or Mobile Access to Health Documents, I think is the current name, which is the MHD profile, which we edited last year. We have Internet User Authentication, so we talked about XUA. IUA is looking at using Internet standards, something called OAuth, or OAuth 2.0. This is specific for it, which is what you use when you use your mobile device to log into Facebook, or log into Twitter, or log into other sorts of applications you might use on the internet, Tumblr. And then we have work that's going on in our US national program around being able to give patients data. And so one of the things that I try to do as a patient is be engaged with my provider and be able to get access to my data. And I want to be able to essentially go to my provider's website and push a button. We call this blue button in the US. You push this blue button, click it with your mouse, and you're able to download standards-based content to your device. And this is starting to become available in commercial applications, and it's using CDA, HL7 CDA specification, in a way that is built on IHE profiles that are developed by the committee for which I'm a co-chair. I also am on the board of HL7, and they, in the last year, started a mobile health work group that is talking about what are the functional requirements for mobile health devices. They have been developing something they call fast healthcare interoperability resources, which uses a way of accessing information that's very suitable for mobile and internet connected devices. It uses something called a RESTful protocol, which is more like a set of published guidelines than it is a standard, but they are actually standardizing the specifics of how you interact with this. I talked a little bit about the work that's going on in the US around the CDA, and this week in the patient care coordination domain in IHE, we are actually harmonizing with the latest version of an implementation guide from HL7 called Consolidated CDA. And the full title is actually the IHE/Health Story CDA Consolidation Implementation Guide, because they started with a lot of content from integrating the healthcare enterprise and a consortium of folks who are standardizing work called Health Story that is an affiliate or an associate of HL7. They just completed a style sheet project that takes CDA style sheets and makes them downloadable as just simple plain text. Because in the original version of the Blue Light, that's all it was plain text. And they have been working on the RESTful protocols, which is a standard called HData that is being jointly developed by HL7 and the Object Management Group, or OMG, on which the Fast Healthcare Interoperable Resources work, what we call FIRE in HL7, is also building off of. The Mobile Health Work Group, their goal is to identify the needs for data standards and functional requirements. So if you are a healthcare provider who's interested in mobile health, or an IT professional who's interested in mobile health and want to contribute to that, I urge you to consider participating in those activities. And they are also trying to coordinate amongst various groups who are interested in using mobile health. Essentially providing a place where people who are interested in mobile health can come talk. FIRE, this gets a little bit technical, and I'm not going to go into all of the techie, geeky sorts of stuff. But the idea here is that this is a simple, mobile-friendly standard that expresses the typical content encountered in existing healthcare applications. And the governance around this is very strong. It's is this something that people can use today, will use, or willing to have, in terms of the kind of content that they're trying to build, rather than trying to, as was done in some HL7 version 3, boil the ocean and put every possible choice in place. And it supports being able to develop richer and more complex clinical models in profiles and extensions to the standard, and there's a very well-structured way in which those extensions are described. This provides some of the attributes, the resource characteristics, and rather than read through each one, this is a list of characteristics that was developed by software developers who were trying to build applications and trying to build web applications and build them quickly. One of the things that we see in mobile health, the market moves very fast. Mobile devices have not been around. They weren't around in 2005. We didn't have iPhones. We didn't have iPads. There are now 13,000 applications. We know there's a lot of applications being developed in a very short time frame. One of the important characteristics of Fire, when it was originally envisioned, was that it would be free for use. Now, I will tell you, as of April 1st this year, HL7 did announce a policy change on its standards. So that its standards, its implementation guides, and its domain models would now be freely available without license fee from HL7 as of the 1st of April. So that might be something for those of you who are looking at standards might be interested in investigating. The consolidated CDA project I already mentioned, and we are working in IHE to complete that harmonization of that, what is currently a U.S. specific specification, and internationalizing that. And we hope to be coordinating with HL7 on actually potentially validating that as an international specification as well to get even wider input. The H data project I mentioned briefly is something that's being done jointly. In terms of IHE, I mentioned the mobile access to health documents, which is designed and fits very well with already existing infrastructures, cross-enterprise document sharing, cross-community access, or XCA as it's known, works well with being able to download and view CDA documents. With the IHE CDA harmonization project we're working on now, to be able to use that in a mobile environment. What I have listed here is an OAuth option is now the Internet User Authentication profile on IHE. I last gave this presentation, I think, in November of last year, so you can see the speed at which some of this is working. And with the mobile health devices, you don't necessarily have devices that are always on, always connected, so that they can receive your notifications. So there's another profile which enables devices which are not always connected to be able to get pull information about notifications of new documents that might be available for download. The mobile access to health documents is intended to be simple access to documents. It's intended to support a RESTful API, an API that works very well on the mobile platforms that are available today, and which you could interact with in HTML and in JavaScript, and in those programming languages that are common across the various platforms. And can also be used as a standalone way to access information, so you don't have to have the HIE infrastructure to use it. You could simply connect your cell phone to your doctor's office. Now, on that point, I just want to make one point to you. I have 5 applications on this device that are all healthcare applications. None of them presently talk to each other. Each one is a silo. When you are looking at the standards that you want to use for communicating with providers, even if you were just connecting up to one provider, a typical patient who requires a lot of healthcare could have many providers. And in the US could be from 15 providers from 10 different organizations that they have to contend with. They do not want to have 15 applications that they have to look at, each one having a narrow, very focused view of their healthcare. They want one application that has all of the data, that is able to speak to each of the providers that they need to speak to their dietitian, speak to their cardiologist, speak to their orthopedic is their plan of care covering their entire health. So one of the ideas behind mobile access to health documents is this is an API that can be implemented by multiple organizations, and yet one application can speak to each of the different organizations. And it gives you a very simplified access to query, to access, and to store documents. One of the other things that's very important in mobile health is now that you have the patient connected to the data, wouldn't it be nice to get the data direct from the patient, perhaps even before they were in the office? This diagram here actually shows an example of how the mobile access to health documents profile connects on both sides, both as the patient being able to generate documents, or the provider be able to generate documents, or the patient or provider to be able to access documents from your HIV infrastructure. In terms of being able to access the documents, you will have to have content standards to work with those. And so IHE is working together with HL7 to harmonize and internationalize their research work in the US so that it can be used internationally, but it doesn't have the US requirements where the address needs to look like the patient lives in the US, or the name needs to look like the patient lives in the US, or we're using the vocabularies like ICD-9 that the US is probably the only country in the world still using. And so trying to figure out how to do that so that you can have your regional policies for these are the vocabularies we need to use, these are the standards we need to use in this country, in this city, to be able to implement interoperability appropriately. So I spoke of Internet User Authentication, which is an IETF, so it's international, Internet Engineering Task Force is the IETF. That is the organization that develops the standards that are used on the Internet. And so they have adopted OAuth 2.0 as one of their standards for use on the Internet. One of the challenges is that this is not so much a standard so much as it is a framework for developing standards. So IHE is working on and developing a profile of that particular standard to enable patients to connect to devices, but also to make it easy for you to maybe take a device like this, register it in a hospital environment, and be able to authorize that device to access health data. So maybe providing some capability to support the bring your own device capability with the right software installed. And that will probably occur maybe as a future enhancement. The first case we're trying to get to is individuals being able to authorize access to data. There are a number of assumptions that are involved in the development of this OAuth work. I'm not going to go into all of these details, but the key point here is that OAuth is designed to work with the Internet protocols and to work like things like Twitter and Facebook do today, where you can have an application that can actually access your Twitter account or your Facebook account. You can have an application that can access your personal health account, or have an application that accesses your regional health information organization. And so you look at an early diagram here of how this works in terms of there being a server that provides the authorization that has a hidden communications link potentially between the health information exchange or the healthcare provider and the any authorization goes through that authorization server, a trusted entity that the service provider can then look at and say, yes, they have provided authorization to access this particular data. And OAuth remains silent on the authentication. So there was a gentleman earlier who had the question about, you have maybe the smart card that you use to identify yourself. What OAuth says is you must authenticate yourself with the service. And then here's the standard way, once the user has been authenticated, to authorize access. So it's a mechanism to support access control rather than user ID. There are ways in IHE today where you can subscribe for information. So your cardiologist could subscribe to information about you from your hospital or from the HIE. But the challenge might be that your cardiologist is in an office where they have intermittent connectivity, or where they turn off the computers at night. And so they don't have always constant constantly connected to the internet access. And so the pull style notification gives you the ability in that environment to be able to download the list of things that occurred that you said you were interested in. That can also be very important in the mobile application. I turn my phone off. When I turn my phone back on, I will get a list of notifications because John has sent another tweet. And it will tell me all of the notifications I missed. And the reason he do that is because my phone will actually go out and ask for that information and get it back. And so this is one reason why this profile is potentially important to the work that's going on in dealing with mobile. One of the important activities that goes on also with mobile health is the ability to do telehealth and remote monitoring. So you have lots of devices today where that you can keep track of your fitness. You can step on the scale and weigh yourself. One of the applications I have on my iPad here is one that I can use to take my blood pressure. You have patients who have devices that can monitor their blood glucose and record that information and store and save and exchange that with other providers. And these are not traditional smartphones or tablets. These are embedded pieces of software in medical devices that are really designed for very specific function. And so Continua Health Alliance is developing standards that are using multiple different ways of connectivity. So my Fitbit connects via Bluetooth to my phone, but there are other ways that you can communicate with other devices, maybe using wireless, or connecting the device up to a computer using USB, or using something called Zigbee for home monitoring, where you're monitoring patient activity. I think everybody remembers the commercial many, many years ago, help, I fall and I can't get up. And you have the little device that you push the button and you call somebody. Well, you have now in these devices, you have standards that are designed to be used in the home and in other environments where the personal area networks or wireless networks that can communicate. And these can all be connected up, and you might have a box, what they call a set-top box. It might sit next to your cable box on top of your TV. That can gather all of this data and transmit it somewhere else. So they're developing the standards to do this with monitoring. Some of these devices that do EKG monitoring and pulse oximetry monitoring. Some of the standards that they've selected are things like a transaction from IHE, which everybody at IHE knows is called PCD01, is just a simple transaction to report observations from one device to another device. And it can report observations. It could be weight, it could be blood pressure, it could be EKG readings. So IHE is also working to continue on some of these activities. And then in the US, we have activities that are organized around our own national program in being able to get patients access to data. And one of these was called REX, and it's actually building on H-data. And the follow-on project to that is called the Automated Blue Button Initiative. It was sort of the ability for patients to not even have to worry about pushing the blue button. They go into their computer and they say to the computer, I would like to set it and forget it. Just give me my data and keep giving it to me until I tell you to stop. So this has become what we call in our national program the Happy Project. And I got to be there when that project was conceived in a White House convened summit. And the fun thing about that was my daughter was already going to be in Washington, D.C. with me, so I got to bring my 14-year-old to a White House convened meeting. This is the Abby Project. Can you guess what my daughter's name is? It's Abby. So somehow they managed to get me involved in this very interesting project in terms of its ability to enable mobile devices and patients to actually get access to their data. Many people here have heard the term e-patient. So you'd think it would be like email, electronic, and it's more like energized, engaged patients. So there's actually a society, of which I'm a member, the Society for Participatory Medicine, that is very involved in patients being engaged with their doctors, being able to get access to their data. And they are very encouraged by this movement towards being able to get their data and being able to use it to help manage their own conditions. And they want to be able to get this data mobily wherever they are, not have to be sitting at a computer or going to the provider's office to get to it. So very, very important. And this project in our U.S. national program is actually aligning with the IHE Mobile Access to Health Documents, which is aligning with the HL7 Fast Healthcare Interoperability Resources FIRE project. And part of the reason it's aligning is because there are several of us who have been engaged in every single one of these projects and making sure they're staying coordinated internationally. So some common themes that I just want to leave you with, things to look into, especially FIRE, the OAuth 2.0 and mobile access to health documents. And the last page here, I have a list of resources which I'll leave up. And if you have questions, I'll be glad to answer them. Otherwise, the only thing standing between you and I think lunch at this point.